Okay, welcome everyone to this month's webinar. We still have some people coming in right now, but we have the team all here. This month we are going to be looking at two areas in particular. So we'll cover that in the agenda in a minute. Just a reminder, the Q&A section is open. Please post your questions. As I said, members of the VIRL team are here and ready to try and answer your questions as best as possible. If we're not able to answer the Q&A, your questions during the session, we will do our best to get that completed afterwards and get those questions, the answers to your questions posted afterwards. Okay, so today we have two topics. Our colleagues Brian, Nicholas, and Giles are with us today. We're going to be starting off with Brian. So Brian was recently presenting at the DevNet Express event in Berlin, which some of you may have attended. And he's going to be covering network programmability, automation, the various APIs, and how you can make use of some of those APIs, both within VIRL and some of the API capabilities, programmable capabilities we have within the operating systems inside the virtual machines. We're then going to be looking at Open Daylight and how that can be incorporated into VIRL environment and get that talking to instances. So we have Nicholas and Giles, both of whom have done extensive amounts of work with Open Daylight and bringing that into the VIRL environment. So two topics that we're going to be covering today in depth. And with that, I'm going to be handing over to Brian, who's going to take us through our first topic, automation and network programmability. So Brian, I'm going to pass the ball over to you.
Okay, thank you. Okay, can you see my desktop?
We can.
Yeah.
Okay, thank you. Hi, everybody. My name is Brian Doherty, and as Joel said, I'll be talking a bit today about automation and programmability with VIRL. So what's ahead? First off, VIRL, as many people may not know, is built around RESTful APIs. Pretty much everything that goes on between VM Maestro and VIRL or the web page in VIRL, the user workspace manager in VIRL, is all done via RESTful APIs. So you can use VIRL APIs to do many things. You can, if you haven't used them before, you can use them to learn, or you can do other useful things like automate the starting and stopping of simulations and so on to facilitate, say, the creation of programs that operate on the VIRL simulations. So what I'm going to show here is very high level, and it's just a teaser. So go ahead and explore more in depth on your own time with the things that you've learned today. So VIRL APIs. So as I mentioned, VIRL exposes many APIs, but the OpenStack platform upon which VIRL was based does as well. There are a number of key OpenStack elements that allow VIRL to start and manage simulations. So for example, with Nova and Neutron and other shared services like Keystone and Glance, they all expose RESTful APIs that you can access via many different facilities like Python, curl, and others. So then we have VIRL. VIRL sits on top. It has its own APIs. Primarily, the main ones that we're going to look at today are from the simulation engine, but also other facilities like the roster service and AutoNetKit and so on provide APIs. So what is an API? For those of you who don't have much programming experience in the past, it's basically just a set of rules, a set of routines and protocols and tools for building programs in a distributed fashion. The API itself is generally defined. It's a set of definitions that describe how that interface operates, the inputs that an API expects, the outputs that it's going to provide, and how you need to format the data that passes in between. And more recently, in the world of SDN, it's really come down to being a means through which we can develop services, control services, and platforms that are in our networks. Basically, in summary, they define methods which are how we say, what do we want to do? Objects, what do we want to act upon? Data that's passed back and forth between the programs, and then formats of how we want to get that data back. So RESTful APIs are all the rage. Generally today, if you hear about an API in the web space or in infrastructure programmability, it's going to be a RESTful API. You'll often hear REST APIs, but RESTful is really a way and not a specific type of API. So it stands for Representational State Transfer. As I said, it's an architectural style that was developed to allow for applications to be developed at great scale. And it uses HTTP and HTTPS to transmit messages between endpoints. So it's something you use every day, perhaps without knowing it. And it operates on resource representations that are defined by URIs. And as I mentioned, RESTful interactions are really the dominant method for infrastructure programmability and automation in data centers and automating the operations of networks. So I mentioned it's built on hypertext transfer protocol. There's two different message types, request and response. A client generally will send a request to a server indicating that it is looking for a specific resource, and the server finds that resource or does whatever action is required and then returns that. Within HTTP, there's three message elements. There's a start line, which is primarily what you see when you type in the URL, and headers and bodies, which are optional. And when you do a RESTful call using hypertext transfer protocol, you get many different status codes back. 200 means okay. It's the one you rarely see because most things tend to work on the internet. You'll often see 404 not found or 500 internal server error and so on if there is a problem on the server side. So RESTful constraints, and this is just an incomplete set. We already talked about it being client-server. RESTful protocols or RESTful APIs are also stateless. So for example, as a client like VM Maestro, when I send a request to the server, and as soon as the server responds, the server pretty much forgets about anything having to do with that transaction. And that's really necessary to allow for a highly scalable interaction between the client and the server. And the requests have to be uniform. This generally means that a request contains all the information necessary for the service to be delivered by the server. The server functionality and state must be completely described in those interactions, and that's really to allow the clients and servers to evolve independently. Lastly, the responses can be cacheable, and RESTful APIs allow for a layered topology. So for example, any server I talk to could indeed talk to a server that sits behind it. The RESTful methods, you guys know these perhaps. GET is something you use all the time when you try to retrieve a resource from a web page, but there's also POST, which allows you to create data on the server, PUT, which allows you to create or replace entire collections of data on the server, and delete. There's others, but these are the primary that we use. And then finally, in our quick little review of what RESTful means, there's two real types of URIs. So if these are the methods, these are the verbs, these are the things that describe what we want to do. The URIs is a description of the things that we want to act upon. And there's two main types, URLs, which we've seen all the time as part of our use of the web. These generally include a scheme name, a host, and then some sort of a path or file name that we're going to act upon. And the other is a URN, which is very infrequently seen. It's just a different way of defining resources. It generally just defines a namespace and a specific string that it associates to a resource. So in general, clients request an object state, server returns the object state, client can specify that it wants that state to be different, and the server can then return the resultant state. So that's the type of interaction that exists between, for example, an application like VM Maestro and the many facilities that are on the back end of VIRL. So that's just a quick overview of how RESTful APIs work. Let's look at some ways that we can actually begin to use them. So with VIRL specifically, there's a number of ways we can get access to the APIs. There's the VIRL CLI, which is sort of cheating because it basically is just a command line shell that makes the API calls on your behalf and returns information. You can use things like Python, curl, which is a command line web or HTTP interface program, and tools like Postman. So we're going to look at using a number of these to do some things with a VIRL server that I have running here. So you might be asking, okay, if VIRL has APIs, how do I know how to use them, what they are, and what they do? So if you look at a VIRL server, and I have a VIRL server running here that's on version 1.0.0, if you go to the user workspace management interface, you'll find a menu which includes documentation. And if you look at the documentation tab, you'll see all the various elements inside of VIRL that include an API. And we're going to look at the SIM engine here, for example. So the SIM engine is responsible for starting and managing the VIRL simulations, and you can see that it has a large number of APIs. And we can do things like look into these. So for example, the SIM engine REST launch API. It's going to describe the type, what the API does, the response that you can expect to get back. So for example, if it's successful, we're going to expect to get a session ID back. And then the parameters, some definition of the various parameters that need to be sent as part of that API call, and then the responses that are not okay, so anything other than a success is also described, and the type of data that you'll get back with that. And you can explore a great many of these APIs. So for example, the SIM engine start, SIM engine stop, things like that. And I'll apologize, I'm going to be going back and forth between a number of screens from here on out. So I already spoke of this. Note that in 1.0.0, unless this has been changed, you'll see a little button down here that says try it out. And that button is intended to show you a specific example. Oh, it's been disabled. Okay, good. So if you have an earlier version that hasn't been updated, that try it out button may show a URL that includes the port number 19400. Just be aware that that port number really needs to be 19399 if you still have an unupdated system. So quickly, we'll just go through the use of a number of these various mechanisms. I'm going to move over here to the VIRL server that I have running. And there's these two applications, VIRL SDN client, and you can do --help, and it's going to give you a list of all the various things that you can enter as parameters to that. I had entered earlier a command that's just going to show me the subtypes that are available on the server itself. And if we scroll up to the top here, you can actually see the URLs that it is using in order to gather that information. So for example, it basically did a get to the server address, and it used the SIM engine REST subtypes API in order to capture this information and then display it on the screen. There's another client as well, the OpenStack client, and you can similarly send commands to it that's going to use the OpenStack API and capture information as well. The OpenStack APIs, you can get definitions for those on the OpenStack, the various OpenStack resources. You can see here it crafted, it knew what API to craft, and it pulled back information that shows the number of vCPUs that we have, the amount of memory, and so on that's been associated with this OpenStack compute host. You guys will have these slides afterwards. So you can also use Python to make calls to the VIRL backend. And I have a number of scripts here that I'm going to use and show you their use to manipulate my VIRL server. So In the directory we're going to look at, I actually have a VIRL XML XML representation of a VIRL topology. It defines the various nodes that are in the topology, the links between them, and the configurations that are associated with each one of the nodes. And I have a couple of different types of scripts. The purpose of this discussion is really to show how you can automate some of the activities with VIRL that you normally might have to use VM Maestro for. So I have a Python script here that the purpose of which is to use the requests library. That is a library that can be imported into Python, allows you to form HTTP and responses and requests and responses. And what I'm doing here is I'm basically just defining where my host is, the username and password that I want to use to authenticate, and I'm defining the URL that I want to send. In this case, I'm going to use this script to launch a topology on the back end without using VM Maestro. So I'm going to open the topology file. I'm going to send some information about what I want the topology, or I'm sorry, what I want the simulation to be named, and then I execute the script. So we come back over here. You can see that I've got these scripts. This LT1 is the one I just showed you. So we can run lt1.py, and it's going to take the name of the simulation that I want to start, so December webinar.virl, and this specific script expects to see a name provided for the topology name. So I'm just going to provide the name, and we'll see here that the script is going to execute. It's going to return to me that it began the simulation named test, and now if we look at VM Maestro, we'll see that it is, in fact, starting a simulation named test that includes the topology file that I just showed you. And we can see this, we can watch this come up. So while that's coming up, I want to skip ahead to another method for interacting with the VIRL backend, and it's this tool called curl. And curl basically allows you to form command line requests that do much the same as what I just showed you in Python. And I have a couple scripts here. They're bash shell scripts that are going to go look at the VIRL backend and get a list of the simulations that are running at that time. So we entered the command curl. We provided our authentication, guest. We indicated the host we want to speak with in the port. This is 19399 is the VIRL simulation engine port API. And then we said sim engine rest list. And it's come back and it's telling us that we have a simulation called test and a simulation that I started earlier, this DNE 37K and so on. We can get even more information by using a different API. So in this case, the API that I used was the roster rest. So I'm asking the roster for more information about the specific nodes that are part of that running simulation. And it's come back with a list of the simulation ID as well as the node that makes up part of that simulation. And you'll see that it's got a great deal of information that if you're skilled in Python or any other programming language that can use the requests library or bash scripting, you can take this information and perhaps parse it and do something useful with it, like take down specific nodes or get information about how to get access to the consoles and so on. So my simulation is up, and I have a second script, a second Python script, if I can find it. In this case, it's going to stop the script. So I'm using a completely different API call. I'm going to pass to this script information about the name of the simulation that I want to stop, and it's going to send a sim engine rest stop to the server and in turn stop that simulation. And it comes back success, and I will be able to look and see here. If I do a refresh, we should see that test simulation terminating. So it's just a means through which you can programmatically manipulate the simulations that you want to have on your VIRL server and do it in a quicker, more automated way than using a graphical interface. So we already talked about these curl examples. I have a detailed OpenStack example that includes getting the OpenStack token and tenant ID, which is a necessary element to have if you want to make calls to other OpenStack APIs. But in consideration of time, I'm going to skip over these here, but they will be in the slide deck. And then finally, I wanted to show a tool called Postman. Postman is a plugin or an add-in to Chrome, and it's a tool that allows you to form these API calls in a graphical system. So you're able to select whether you want to get or put or post and so on. You form the URL that you want to send. You can authenticate. So, for example, I know that the VIRL backend isn't going to provide anything to me unless I provide some sort of authorization. So I'm going to provide guest. And then I can send that request and get the results of that request back immediately from the server. In this particular call, if you use Postman just to query your server address and just the simulation engine port, for the services topology director port, 19399, it's going to come back with a full list of the various APIs that you can potentially use. So, for example, I still have running simulations. I could do APIs to get access to those simulations. I could do AutoNetKit REST test, which is just a API that's going to come back and tell me that AutoNetKit, what the AutoNetKit version is, and so on. So you can use Postman to do live querying, live testing, and interaction with the VIRL backend. And it's a tool I would recommend that you get and can even use against any VIRL deployment that you have today, particularly this command that just uses the port number that gives you information about all the various APIs that are available. And you can query these live from Postman. One other interesting feature of Postman, by the way, so say, for example, I have this SimEngine REST jobs. There's this little code button over here that will show you how to form that particular API call in curl or in Python and so on. So you can get a number of different indications of how to use these APIs in various programming facilities. So I already described this live. I'll just forward here a little bit. There's a number of different slides in this presentation that show you how to get information. For example, list the simulations, list the nodes that are associated with a simulation, list the interfaces that are associated with a simulation, and so on. So that's just a brief and quick overview of what a RESTful API is and how it can be used with VIRL. There's also the ability to use RESTful APIs with the actual nodes that are running as part of a VIRL simulation. So there are some new versions of iOS XE and iOS XR. They're going to have programmatic or model-driven interfaces in the future, and you'll be able to use these same techniques to do things like add routes to the route table, bring interfaces up and down, and so on. But that's something that's coming in the future. So what next? I'll finish up here. Just if you don't already have VIRL, get it. When you have VIRL, you have a platform that you can use to play around with APIs on your own. And you don't need to be a programmer. You can use the tools that I've shown you, like Postman, just to get access to the VIRL backend and begin to learn how these APIs work. So that's it. Thanks.
Okay, thank you very much for that, Brian. So leading neatly on and going into another area of programmability. We've got Giles and we've got Nicholas, both of whom worked extensively with the Open Daylight controller. And they're going to look at Open Daylight and how that can be incorporated into an environment where you've got instances running in VIRL and Open Daylight talking to that. So Giles, Nicholas, all yours.
I think, Giles, you're on mute, so I'm going to unmute you from here. There you go.
Thanks for that. I'll repeat what I just said. So yeah, I was just saying thanks, Joel, for the introduction, and I guess by design, a lot of what Nicholas and I are going to present follows on quite naturally from what Brian's just presented in terms of things like REST APIs and being able to use Postman to exercise those. What we're going to do briefly is I'm going to give a background on Open Daylight and talk a little bit about setting up an Open Daylight VM. And then Nicholas is going to talk specifically about how you can hook that into VIRL, and then look at things like different applications we can run on top of Open Daylight. And an example he's going to give there is a demo of an app he wrote called Pathman, which is a pretty nice application for basically discovering network topologies and then configuring MPLS label switch paths across those topologies with PSEP. We've got some resources, and one thing I'm actually in the middle of doing right now is uploading an Open Daylight VM to Box that you guys will be able to have access to afterwards, as one way of running Open Daylight rather than having to set it up for yourselves. So in terms of Open Daylight itself, here's the official picture from the Open Daylight Lithium release. So like most open source projects, Open Daylight has a naming scheme, and in our case, that's based on the periodic table. I think it's probably fair to say the diagram that we ship with each release saying what components there are is starting to look every bit as complex as a periodic table. But looking at this diagram from top to bottom, at the top you have various APIs which are hand-coded and set on top of Open Daylight. So the Deluxe user interface, I'll show you. Open Daylight itself implements, for example, OpenStack Neutron. But those sit on top of a layer of automatically generated APIs. Now, those APIs can be generated both as internal Java APIs and as RESTful APIs, and the technology there is called RESTconf, and I'll come on to that. And then within the controller itself, there are various network services that run. Now one thing about this picture, I guess, that's fair to say, and even one or two of the next slides up, is that they're coming very much from the perhaps traditional view of an SDN platform, where an SDN controller is seen as being more or less synonymous with OpenFlow. And if you look at the left-hand side of those green boxes, you can see everything there is really OpenFlow related. And if you look at towards the bottom left, you can see OpenFlow devices, Open vSwitch, and OpenFlow as the first of the southbound interfaces that are listed there. But what you can see, of course, is that Open Daylight goes way beyond that. So there are dozens now, literally, of different southbound APIs with Open Daylight. So the ones we're going to focus on today are towards the left. So it's netconf, and Brian talked about APIs onto routers. We already have netconf APIs onto iOS XR. I believe, as Brian said, what's coming is REST interfaces also for XR and for XE, and I believe netconf for XE. And then we have BGP and PSEP. Now, those work together very much in Open Daylight applications. So with BGP, we run a BGP address family called link state. So it's BGPLS. And then so BGPLS is used to learn network topologies, and then PSEP is used to program them. So everything we're doing here is very much about communicating with routers with those three protocols, hence wanting to hook through to VIRL. If you're just doing OpenFlow with Open Daylight, then you can use just an emulated OpenFlow environment like Mininet. But since we're going to routers, obviously there's great value in using something like VIRL that lets us easily build large topologies of virtual routers. So Open Daylight has a user interface, which is called Deluxe. I have to say I'm not a big user of the user interface myself. I tend to go straight in with REST APIs. So, but as Brian was explaining, I use Postman to exercise the APIs directly, and then I tend to write Python scripts that can then call those APIs and do stuff. So I think one thing that's worth talking about, having mentioned that, I don't see SDN as being just about OpenFlow. What is it that we see SDN as being? And so I guess I see more or less 3 layers to it. So the first layer is just syntax conversion, and to some extent also providing a single point of access to the network. So instead of, for example, with netconf, you can communicate using netconf to each router in your network, but then in terms of writing your client application, you have a couple of issues. One is you're going to have to connect separately to each of those routers, but the other key issue, I guess, from a syntax point of view, is now you're going to have to implement both netconf XML, but also you have to understand the encoding on the wire that's used by netconf, where it runs over SSH using something called chunked encoding, which gets a bit complex. Now, REST and JSON is a much easier world. So from Postman, you can access it manually, and from Python, literally, once you include the requests library and the JSON library, it becomes very, very easy to write code. And the same is true for BGP. So when OpenDaylight runs BGP, now any of you who know BGP well know that, like a lot of IETF protocols, it's TLV encoded, so it's very binary encoding. And again, it's nice to have a very simple JSON representation of that. The next layer is, I call it semantic translation. So really talking about how do we take that data that we've gathered and then use it to do something more interesting. And the key abstraction in OpenDaylight is the topology. And so it's taking something like a set of NRIs learned from BGP and turning that into a graph where the graph consists of nodes and links. But then abstraction also can mean other things. So one great thing, having a single topology model that then can be specialized for different technologies. You can write code that doesn't actually care where it's learned that topology from. It just knows it has a topology. And equally, you can build applications inside OpenDaylight that provide more abstracted APIs. So a good example of that was a few of us were at there was a MEF lifecycle orchestration hackathon that was attached to the MEF Gen 15 conference a few weeks ago in Dallas. And what we were looking to do there was create a standardized MEF API for provisioning MEF services across the network. So that's things like Ethernet private circuits and provisioning those across the network, but being able to do it in a way that's decoupled from the underlying implementation. So, is it VLAN switching? Is it a pseudo wire? Is it a VPLS? Or even, is it a Cisco router or something else? So the next thing to talk about with OpenDaylight is, what is all this netconf and restconf and Yang models that I'm going to talk about. So those of you who know SNMP could see how this kind of stack that I'm showing here would fit into an SNMP world where, at the top you have MIBs that are your kind of definition of what it is you're managing. And that then gets encoded on the wire. And in the SNMP case, that's ASN1 encoding. And right down the bottom obviously with SNMP, you're using gets and sets and you're running over UDP. In the case of netconf, as I mentioned, we use SSH normally as the transport with this chunked encoding on top of it. Then effectively, the mechanism we use to interact with the network device is an RPC mechanism, so remote procedure calls. On top of that, we define netconf operations like get the config, get the operational stats, etc. And that's encoded on the wire using XML. But the models that define what the XML is going to look like, that's using this modeling language called Yang, which is documented in an IETF RFC. That's RFC 6020, which is pretty much my Bible when I work with a lot of this stuff. The follow-on to that, though, is providing a REST API to all of this. So RESTconf initially is just saying, do exactly the same as you do with netconf, but instead of using SSH transport and this chunked encoding, let's use a standard REST approach so we can access it from things like Postman and easily from things like Python. And as part of that, we've also added JSON as an encoding. The IETF has a working group called I2RS, and they're working on Yang as their modeling language. What I2RS hasn't yet done is exactly defined how they're going to encode everything on the wire. But OpenDaylight itself makes very wide use of these Yang modules. So every interface in OpenDaylight is defined using a Yang model. So let's talk about netconf and how we're going to use that. So the key concept here, and this came from an IETF activity where they asked basically the operators what is it they wanted from a network management system, and they asked for things like transaction support and well-defined schemas and that sort of thing. So netconf does that, and the way it works within Open Daylight is that you configure in a config file what all the nodes are you're going to manage, or you can use the REST APIs on top of Open Daylight and you call those to add nodes to the network. Now in the future, hopefully we'll be able to have nodes more auto-discovered where nodes almost find the controller rather than the other way around. So Open Daylight would connect to each node, and with each node, it'll learn the Yang models that the node supports, and it'll not only learn those against the node, so now we have an inventory of what the node can do, but also it'll cache those models locally. And from those cache models, that's where we generate these APIs, both the RESTconf API, the REST API on top of Open Daylight, but also internal Java APIs. And the cool thing there is all this is done at runtime. And what happens if you connect to another node that's running the same version of the same operating system is you get another node in the inventory, but the cache wouldn't need updating because you already have all those models. But if you connect to a node with a different operating system or even a different version of the OS, that's where we, talk about versions, that's where the Yang models have these dates after their names in the cache, so that if the Yang model's been updated, we would store a separate version of it. And then to configure a node, again, using the RESTconf API, you can make a call saying you want to configure a node. And I've given an example there of a URL. And this is one thing you discover quite quickly dealing with these REST APIs is because the REST model, all of the state is really in the API call itself, you do tend to end up with these very long URLs. And it's quite a skill, I guess, within Open Daylight to learn how to walk these URLs and figure out what the URL has to be. But at the end of this presentation, we've got some resources, and some of the links there will help you do that. And so when you configure a node, effectively what's happening within Open Daylight is it's converting that REST operation, a post or a put, and it's converting that into a netconf operation to the device. And the way it knows which device to access is because in the URL, you've got the name of the device. And you've got this interesting statement, yangx mount, which is saying you want to actually access a data store on that device. So it's a remote mount of that network device's data tree. And yeah, we can also retrieve statistics and config using gets. So it's a normal HTTP get. And so all of that's very, very usable through Postman. So I wanted to quickly talk about topologies, and really everything in Open Daylight is a topology. So using BGPLS, we build a link state topology. We have IPv4 and v6 unicast topologies. PSET builds a topology. OpenFlow builds a topology. Even the netconf nodes that we've configured are stored as a topology, even though that's a topology that's just nodes, not links. So BGP link state is an interesting protocol and really great thing in terms of getting visualizations of traditional routed networks, in that whether you're running OSPF or ISIS as your IGP, as long as you have at least one node in the network that can talk BGPLS, so that node can be any XR device, or there are other devices that talk it as well, that device can then effectively distribute that link state database from the IGP and put it into BGP NLRIs. And so if you're configuring a router to do BGPLS, you'll see a statement under OSPF or ISIS saying distribute BGPLS. And once you've done that, then the data will make its way into BGP. Now, of course, the BGP config, you'll have to add the link state address family. And on the neighbor that you configure for Open Daylight, you'd add the link state address family as well. So ODL will learn all those NLRIs, but those NLRIs identify nodes, links, and prefixes in the network. And those prefixes are the OSPF or ISIS prefixes. So what then happens is we have a topology builder that turns that into a topology view. And that topology is a list of nodes and a list of links, where the link's attached to the nodes. And there's the URL there that you can use to get at that topology. So PSET then works with BGPLS. So what we tend to do is use BGPLS to learn the network topology, and then PSET to program LSPs into the network. And Nicholas is going to show that in his Pathman application. So what happens here is the PCE, so the path computation element, which in this case is Open Daylight, basically is creating MPLS label switch paths on the path computation client, which is the router. So it's very easy to turn this on in XR. And you can then modify LSP paths after you set them up, and also, of course, delete them. And these are purely dynamically created LSPs. But there's a second model where you configure an LSP on the router, and here's the config snippet for it. And in this case, then what you do when you configure the LSP, you can see at the bottom it says path option 1 dynamic PCE, and then PCE delegation. So we're saying, I'm not going to give the path for this LSP as I would normally. I'm going to rely on the PCE to give me a path. So what will happen then is within Open Daylight, we'll use the update LSP RPC to set that path up. And I'll do that by knowing the address of the router and also the name of the path that we're going to configure. The other thing we can do with BGP and Open Daylight, and this is kind of separate to the whole BGPLS and PSEP piece, what we can also do is interact with IPv4 and v6 routes and with FlowSpec routes. Now, FlowSpec is a little like OpenFlow in terms of being a match action type thing, but it runs over BGP. The issue there is you need hardware support for FlowSpec, so it wouldn't be applicable to VIRL. But for v4 and v6 routes, as well as learning them, you can also advertise them, and this is what I'm showing here. So you can use Open Daylight as a way of configuring routes that will then be advertised into the network. So really, you're using it as a sort of route server. And in fact, given the BGP support in Open Daylight, you can use it as a route reflector or route server. And so we have various applications we've written for customers where this is what we've done, and we've basically written apps that talk to the REST APIs on Open Daylight and use that to advertise routes into the network with BGP. So in terms of setting Open Daylight up, there's a few different ways you can do this. So you can just download an image and install it. So you just go to the Open Daylight website, download the image, and then unzip it and run it. You can either get the released images, which I've shown there at the website on downloads. There's also a URL below, which for some reason highlights as the URL, and that's for getting the latest snapshots that they build. Or you can create a Linux VM and install that image onto it, rather than running it natively on your machine, in OS X, etc. Or what I'm halfway through posting at the moment is a pre-built virtual machine, which I'm putting on Box. So you just be able to download that virtual machine, log onto it as Cisco with a password of Cisco123, and there will be a pre-built virtual machine that you can use for testing Open Daylight. Or alternatively, you can buy a commercial controller. So Cisco has a commercial distribution. I believe other vendors are doing that as well. Then to run Open Daylight, once you've unzipped it, you just go into the bin directory and run the caraf command, or you can run the start command to run it in the background. Now, in that case, you then have to go in and add features. The Open Daylight model using caraf means that when you start Open Daylight, you have this caraf container, which has a command line you can access, but very few features are installed by default. So if you want to run BGP, for example, you have to go in and add that feature. The alternative approach is just to run these prepackaged scripts that we've got in the pre-built VM, where those add all the features you need and start everything off and configure everything you need. And that's probably a better approach in general. What I tend to find actually is I really initially wrote those scripts for my own use, because one thing you find is that when you restart the controller, there are various directories that have to be cleaned out and that sort of thing. So rather sort of unzipping it each time you run it, it's nicer to have a script that just cleans everything out and off it goes and runs it. And once you run that start ODL script, then Postman will be able to talk to the controller because it'll be up and it'll have that API. But also using this config ODL script, you can then get it talking to the network. So using netconf to mount the different XR nodes in the network and communicating with one of them using BGPLS so you can learn topology, and then also using PSEP to create LSPs. Though the issue for that is you need some scripts that Nicholas has, because there's no netconf API for PSEP, so we're having to use CLI to configure that. So having mentioned Nicholas, I think probably best if I hand over to Nicholas for the second half of this. So Nicholas, if you want to grab the ball, and then you can go through your stuff.
Okay, thank you. I'm looking where to do that. Maybe, there it is. Valerie, can you move the ball to me?
Sure thing.
I don't seem to have the rights to grab it.
Here you go, Nicholas.
Okay. And we need to find the... Okay, I just going to show a few slides and then show some content from demos. And as Giles was saying, there are a number of places you can put ODL, and one of them is inside of VIRL. It may not be the best practical place to have it right now. As you do changes and it's dynamic content, you need to redo those changes every time you start the sim, or you need to do snapshots of your image. So having it in a separate either VIRL file or a separate VM may be more convenient. That may change when we get more LXC and Docker support in VIRL. So in dcloud, we usually run it as a separate VM outside, and then we make sure that that VM and our VIRL topology are closely associated with IP addressing and such. But our demos also allow you to run it locally on your laptop, and that comes into some scripts that change the addressing or update the configurations on the routers on the fly. To get your ODL to talk to your routers, you need basically three things: netconf if you want netconf, BGP-LS, and PSEP. And there's a difference in which direction, who initiates the sessions, and usually netconf is initiated by the ODL server, and BGP-LS comes from the routers. And you only need one BGP-LS speaker per link state domain. I think you're allowed to have more than one. So in our setups, in our Open Daylight demos, we did not only create them as a demo, but also as a building block for you to develop your own applications, either using our Open Daylight server or hooking your Open Daylight server up into that topology. So there are a number of REST commands where you can change the configuration of the routers to adopt to your server. We also allow for different topologies. We have a number of preset topologies that you can switch between inside these demos, and here are two examples. One has 3 extra servers. One has a shared LAN. The iOS router sits there is there for routing purposes to help with the access to the different networks. And what I've done is I've taken one of these topologies, the left one, and I changed the configuration of server 1 to, instead being the minimum server profile or flavor, I changed it to be the large one, and I installed Docker on it and added Open Daylight. And to install Docker on a server is pretty straightforward. Make sure that it's updated and then install Docker. After that, you need to download the distribution, as Giles pointed out earlier. You need to build your own Docker file, and then basically build it. And when you run it, these are the ports that you want to have open. So 8181 is usually where the service is being serviced. 8080 is the old REST conf address. 179 BGP, 830 is netconf, and 4189 is PSEP. And usually it's a good idea to map an outside volume like /temp, so you can see the log files outside your container. And here's an example of a Docker file, a working example. May give some errors, but last I tried it was working. Actually, this is the one I used in this setup. So let me stop that and go to this one. Here is the server. Oh, not sudo. So we have a Docker container with the ports open that we saw before. We have a router. The router is on the same. And if we look at BGP, we see that port is connected to 118. And 118 happens to be the IP address of this server container. You see right there. And what I can do then is I can jump to my Postman app and look for PSEP topology. And we see that we have a PSEP topology from our router or from our Open Daylight server runs inside of VIRL, and these are our VIRL routers that we see here. And if we look at the link state topology from 118, we also have a full BGP link state topology. There's a lot of output there, and of course, the easiest way to do this is to send the commands through Python's request library and then parse it and grab the data that you want. And that brings us to the next step of the demo. I need to change so I'm disconnecting from this session and connecting into another. So while doing that, we can take a look at this may be hard to see, white on white. This is my local little server where I installed the same Open Daylight server, and I pointed it into the demo. I also connected it into the demo with a OpenConnect client. So this little host is connected in, and it's running the same ODL Lithium as I did in VIRL, but now I'm running it on a small appliance or an Intel NUC at home. And if I go back to my Postman and we look at PSEP, and I change the IP address to my local. I did not program PSEP on that one yet. Let's see if link state is up. Well, we're talking to it, but it doesn't seem to have reconnected into the topology, unfortunately. See if I can get in there.
Nicholas, do you want me to find a goat to sacrifice the demo gods?
Yeah, I'm trying to connect in to my session, and it's not. Yep, I'm getting there now. So the last thing we'll see is Pathman, which is an application built over REST-conf and manipulating the information from the BGP LS topology and creating a map. And on this map, you can then create new LSPs. The front end is built in Java, and we pick a router as a source and another router as a destination. And the application will then find every possible path between the two locations. So, and I don't know how well this updates over WebEx, but as you move your mouse over the different lines or the different paths, it will be displayed, and you can then select one, name it, and deploy it. And this is done on the OpenSDN controller, but we also have this app posted on the Cisco DevNet GitHub for you to download and play with in your own setups. So
yeah, in fact, I've put it in the VM, the package VM I'm uploading to Box as well, Nicholas.
Okay, yeah, excellent. So we're at 9:57. Joel, how do you want to finish up? I looked briefly for questions.
Oops, sorry, muted. So, Nicholas, I was going to say, if you had to give people a good place to start with SDN, sorry, with SDN on the one side, but particularly with Open Daylight, are there tutorials or examples that you would suggest? Oh yeah, go and take a look there, whether that's from the Open Daylight Consortium or whether from Cisco. Is there a good set of resources that you'd suggest?
I would start with logging on to Cisco dcloud, dcloud.cisco.com, and inside there you can sign on with your CCO username password, and you can start and schedule a Open Daylight demo, Lithium, for example, or the Cisco OpenSDN controller. And with each one of those, there's documentation, some very sparse, some a little bit more. And you can play around with the topology. You can access the routers inside there, running in VIRL. And I think that's a good starting point to get your hands wet.
Yeah, and we've also on the deck from today, I think the last slide, I put some links to some various resources, sort of wiki posts that I did and things like that. Have a little self-serving, because some of them are my wiki posts, and one of them's a video of me talking at the ODL summit this summer. But yeah, but it also has, for example, yeah, exactly. But also it has links to GitHub where we have, for example, a whole bunch of Postman collections, some sample Python code. Because really, I think the way I look at it is, yeah, maybe do those demos, as Nicholas has said, in dcloud. But following on from that, I think really the path that I generally take when I'm trying to do something with Open Daylight is start by using Postman to manipulate the APIs and to figure out what's there. Then, start writing Python code that sits on top of those APIs that does what I want, and then maybe put a front end on it. And then longer term, if you want to have an app that's really high performance, you can look at building the app in Java inside ODL. But really, 90% of the time, you can get done what you need to get done just using the REST APIs and calling it from Python, using, as I say, using the requests and JSON libraries. It's really, when you think about it, it really is a very, when you compare it to writing expect scripts and that sort of thing, or parsing, show responses from routers where you're trying to look at the routing table or whatever it might be. This REST JSON world is a whole lot easier. And for anyone on the call who's in that background of operations where they're writing those sort of scripts and using Perl and expect and the rest of it, all I can say is I used to do that 10 or 15 years ago, and life is a whole lot easier with this approach.
Things have actually improved. Okay.
Yeah, which is
right.
nice. And as I think, as Brian was saying earlier, the other great thing is, APIs are coming on the devices. So, watch this space. And as the devices get REST APIs, that'll be an even easier way of going straight to the device without needing a controller. I think the real value that a controller has, as I said earlier about the sort of layers of functionality, I think the stuff around topology and abstraction is really where the value is. And, as Nicholas has shown in this app, it's really powerful once you have that topology.
Yeah, no, absolutely. Okay. Giles, Nicholas, thank you very much for your time. We are at the top of the hour. We've just got a couple more bits and pieces before people take off for the day. Valerie, over to you.
Hi, Joel. Sure thing. So grab the ball back. All right, so here we go. So just a reminder that we had the VIRL 1.0 release back in Thanksgiving Day, and it's now available for download. If you don't have the image, you can email us at ciscovirl@cisco.com to get your image. And then here are just a list of the new features that we have introduced on our YouTube channel. So you can go take a look at the features and then get started on them if you just downloaded and not sure how to get started. Another reminder that previous versions will stop supporting them starting Christmas Day, so you want to get your new download as soon as possible. And then the other thing we want to remind you guys is you might have heard already that we are hosting a VIRL user story contest on our community forum. We would like you to send to us your VIRL experience and stories and how it has helped you achieve your goal, whether it's studying for a certification or self-studying, or you're using it at work. What success stories you've had, we would love to hear about them. And we're picking 3 winners for this contest, and they will each get 2 months extension of VIRL for free, and then you can also get some awesome VIRL swag. So I really suggest that you guys send in your stories. The contest will end on the 20th, and then the winner will be announced on Christmas Day. So that's all. Joe, any final comments?
No, that's it. I'd just like to, again, say thank you to all of our presenters today. So Brian Doherty, Giles Heron, and Nicholas Montin. Thank you for taking the time to give the presentations today. As usual, all the material is going to be posted. We'll have the links that Giles mentioned, including that link to the ODL controller. So that's going to be available from Box for download, so you can incorporate that straight into your VIRL environment. The material that Brian's posted, obviously the slides, etc., the links that Giles has mentioned. And as usual, there's a lot of information available on the support forum. And I'd just like to remind people, there are a lot of videos that have gone up recently of new functionality, new capabilities that have been released in the VIRL 1.0 release. So if people haven't had a chance to take a look at it, I would strongly recommend taking a look, particularly the new capabilities like the RouteM control plane generator, the ostinato generator, OpenVPN, just to highlight a few of those. And with that, I'd like to again say thank you to the rest of the VIRL team for been helping field the questions from everyone today. We haven't been able to get through everybody's questions, but we will do our best to get those answered over the next couple of days, and we'll get the transcripts, the Q&As, etc., posted up onto the community forum. This is obviously our last one for the year. And I'd just like to say thank you to you all as our customer base. We've been going for a year now, and we really appreciate the feedback that you guys are giving us, and hopefully you're enjoying the new features, the new functionality that we're adding into the platform, and more to come as we go into 2016. Okay, thank you all very much for your time, and we're going to close up there. Thank you.